In previous episode, we have seen what is the race condition in the multi-threading and how we are resolving that. So for example, in this case, we have a very simple example. We are creating a two thread, and each thread, what it does is, each thread increments the counter 40,000 times. So how we make sure that we are correctly incrementing that? So what we do is we move the counter into the increment method, and in the increment method, we make sure that and we added the synchronized keyword. So we make sure that this method is accessed only by one thread at the time. So what happens is that the JVM creates a monitor, or let's call it a lock, which can be accessed only by one thread at a time. Only one thread at a time has a key to that lock. So that way, using a synchronize, we make sure that we get the predictable result. That's one way how we are resolving the race condition. Another way is to create explicitly lock here. So for that we are using locks from the concurrent library. So one of the locks is the ReentrantLock. So what we do here, we are creating a lock, and the logic that we have here, right? Instead of using the synchronized keyword, what we do is we are explicitly creating a lock, and we are locking when we access this method, and we are incrementing the counter, and then we are unlocking. So we are releasing the key, and another thread in the queue can access this method again, can access this part of the method. So what's the advantages of using the lock instead of the synchronize? One of the advantages that I see is that, for example, here, right, let's say that we have another logic, and we have some logic prior to the lock, and we have another logic after the lock. So that logic, for example, prior to this one, right, it can be performed we can only lock the part of the code that we want to be accessed by one thread at a time. So that is the one advantage. Another advantage is that this lock class, ReentrantLock, has a lot of methods, a lot of useful methods that can be used, for example, try lock and the similar. That's the one way, and that's the one class in the locks library. Another one that we have here is the ReadWriteLock. So what's the ReadWriteLock? The ReadWriteLock is that, as by name you can tell that ReadWriteLock is that we are separating that reading and writing to some data or some shared resource. We are separating that to two methods. For example, in this case, we have, let's say, again, shared resource, or let's call it the data, and we are writing some random value to that data. So and we have two methods, write, which is that we are writing value to that data, and the read, that we are reading value from that data. So this read method here, it can be accessed as many threads as possible. So for example, in this case, what we do, again, we are creating a ReadWriteLock, reentrant ReadWriteLock, and we are acquiring a lock, and we are performing some operation. In this case, we are just printing the whatever value of the data, and we are unlocking that, right? So that's the one way. So that's how we are doing the read. And what's the advantage of it? This read method, it can be accessed as many threads as possible. For example, 50 threads at a time can access this read method. But if let's say 51st thread is accessing the write, in that case, all the subsequent threads, they will be blocked. Doesn't matter, read, write, and all of them will be blocked until the lock is released here. So that's the advantage of using the ReadWriteLock, because let's say that our class or our application is read heavy, then in that case we can use here reentrant ReadWriteLock. So let's run it and see that what we are doing here. In this case, we are creating two runnable, right? The writer and the reader, and we are starting two threads. One is the writer and the two readers. So if we run this, we can see that what happened is it can happen. Let's run it one more time, and yeah, it can happen also in reverse. So readers, they can access that shared resource, so they can run in parallel. But once the writer accesses that log, so these two threads are blocked until the writer releases that log, right? Let's run it one more time. Okay. Okay, for example, in this case, right? Let's say that in this case, we have, so first what happened is, lock is acquired by the writer, and the writer accessed the shared resource, and all the subsequent threads, thread 1 and thread 2, blocked until the lock is released. But after the lock is released, it can be accessed by as many read threads as possible.